Okay, so I'm just going to go over our week 2 assignment to make sure we are on point. So a couple of things are probably going to happen at this point. So you should have received some type of communication with me as to how you are going to meet up in groups. I talked about that last week. You should have either received an email or a survey or both. So please make sure you do that. I'll be sending out a reminder to those of you that have not. All right, so for week 2, let me go ahead and share my screen. I don't believe I am sharing my screen. So for week 2, what we're going to be doing is we're going to be working on something titled measurements and density. So get this going. Here we go. So our information can be found in the folder that we talked about again probably last week, course content. So please make sure that you try to stay up with the class. You may have missed some of the information from last week, but I'll try and deliver as much of the information in a verbal form as possible. I think that usually helps people to see and manipulate these things, and I'll try not to be too long. All right, so for experiment number 2, measurements and density, we'll click the handout. It's basically an HTML document, and I like to expand it a little bit. And so it'll look a little messy for you guys. So it'll look something like this. And so for this one, this is another individual report. Week 3 will be a group type of atmosphere. So you guys are going to need to figure out when you guys are going to meet. And by the way, if I sent you guys some group times with maybe a broad time, maybe like a Monday, Wednesday, 8 to 12, it doesn't necessarily mean that you have to meet during those times. I'm just trying to get you guys coordinated so that you guys can fulfill some of those blocks of time so that you guys can meet. So I want to make sure that's clear. Okay, so for measurements and density, what you're going to do is you're going to probably want to watch this video, a YouTube video. And then for this one, we're going to have 2 simulations, and you'll be hearing me call them SIMs, S-I-Ms, in my speech to you and via this document as well. And so the first simulation we're going to look at is the one that comes from this website here. So instead of me going there, I already have this open, so I'm just going to push that over here. And actually, I'm going to split the screen so we can follow along together with what the directions are. All right. So a couple of things you need to be aware of. This simulation may act a little clunky sometimes. So you may need to either refresh it, or you may need to use the other simulator that I give you that we'll go over. Okay, so you can do a couple of things here. You could change this water or this liquid into water. You could create a fluid, which is, you can create an object which is randomized. So you should play around with this simulation to see what it has to offer. So one thing that you're going to want to do is you're going to want to place this object in the water and see how much water it displaces, right? So in this case, 25.5 minus 37.5. So this object has a mass of about 12 milliliters. And so remember, a milliliter is also equal to a cubic centimeter. So you want to make sure you kind of keep that in mind. Also pay attention to the various units in the document. In just a second, you'll see me modify the units from grams to milliliters. That's, or I'm sorry, from kilograms per liter to grams per liter. You see me toggle between those two. Okay. And so what you're going to notice here is that the lesser the density of the liquid, the more prone this object is going to be to floating. So, for example, maybe you're in the Salt Lake or the Black Sea, one of those lakes. Those lakes have a really, really high salt concentration, and if you've ever been there, you'll know that people just basically float on the surface of the water because it has such a great density. So, in any way, you could modify the density of this liquid here. You can change the mass of the red object by simply using this slider. You can change its volume. Now, these objects down here, these 8 objects, you won't be able to do. You won't be able to do that too, all right? But one thing that you're going to have to pay attention to is dropping an object in here that floats. So I often see students get that part mixed up. So if you have like a piece of ice, you're gonna, and the density is something that makes it float, you're gonna want to see how much mass it has by taking the difference between those two things. Okay, so you can kind of, doesn't really matter what the density of the fluid is. This object here, the ice cube, is going to still have the same mass associated with it. Okay, and so you're going to also put it on the scale. I'm sorry, it's going to also have the same volume associated with it, and so that volume is in either milliliters or cubic centimeters. So let's make that correction if I said mass. So mass is measured here in grams or kilograms, which you should be able to convert. Okay. The other simulation that you're going to want to look at comes by way of a PHET simulation on Colorado's website. And so let's pull that one up as well. I also have that ready to go. So let's go back to what we had before. And let's stick these two things next to one another so we can read the directions and follow along as best we can. So so I'm working off of the top, no, off of the left simulation this time. And you're going to have to kind of play around to see which one is going to meet your needs the best by way of simulation. So the other thing that you can do with this simulation is you can keep the objects of the same mass, right? So this object here has a mass. All 3 of these objects have the same mass. You can make them all the same volume, and you can make them all the same density, right? So you're going to want to play around with that as you explore this simulation. So I'm not going to give away all that you need to do. You're going to probably need to play around as best you can. So these are some exploration questions here that you're going to want to go through, right? Some of them don't have a really precise answer. So for example, let's see one, well, this one does, which materials sink, and by materials, we can clearly see the materials up here in that simulation. In this simulation here, it doesn't really tell us the name of the simulations by way of, is it aluminum, is it copper? Is it gold? What is it? So you're gonna probably want to just specify that in your exploration of these questions. Okay, now down here, we want to be a little bit more precise, and we want to make sure that we understand how to find density. So density, and density is typically in most books used by the Greek letter rho, R-H-O. Looks sort of like a P, and it's equal to the mass. That's what you get when you put it on the scale, divided by the volume. And the volume, again, is what you get when you place it in the water. Fully submerge the object. So make sure you're clear on that. Okay. Now, some of this stuff, I'm not the best at formatting certain situations. I've done my best here. Sometimes you will see something, and I'll try and kind of unstick this, but this paragraph seems to want to stick, but this is its own header for number 6. Okay, and so where you see the red writing, you're going to want to replace that with your own calculation. So you're going to want to delete that, and you're going to want to put in whatever is the appropriate answer in that area. Same thing here, you're going to want to delete that and place in your own, in this case, pictures. So you're just simply going to do some screenshots and place them in there. Make sure that you give credit to the website that you snatch these from. So as I said here, you need to cite your source. Right? Other than that, again, this is an exercise in you understanding not only units, so pay attention because I toggle between kilograms and grams. I also toggle between liters and milliliters. And if you do a little exploration on the website, out there on Google or whatever your site is, you may even see something in terms of kilograms per cubic milliliters and cubic centimeters. And a cubic centimeter is basically equal to a milliliter. Okay, so you're going to want to go through all that and make sure that you submit this by the due date. It should be on the Dropbox, and it should tie into this date as well. Whatever you're reading this on another in another semester, make sure you look at the Dropbox date because I tend to reuse these. All right. Other than that, if you have any questions or concerns, please feel free to shoot me an email or give me a call. Take care.